solve this. I will go on later. I haven't solved the thing. Yeah. So, hello. This is a YouTube channel, hopefully, in which I program and I try to explain what I do. In this particular series, I will learn along yourself a thing. In this particular case, I am learning Haskell, and I'm doing so by reading the Real World Haskell book, and I am implementing the binary parser of the PGM thing. It's chapter 10, and I will do so while speaking, and here it is already. I did not start from scratch, but I will try to explain my process from scratch. And my setup is just a browser here. I'm using Qt browser and Qt browser, sorry. This was because I don't even know how Stack works. I'll explain the basics of Stack so that you can follow along. And I also have tabs in my browser. Now I only have Real World Haskell, so that's the only thing I'm going to read. I have Vim here. It is open inside of that folder, which contains a Stack project. Oh, that's cool. I don't have a list. Oh, yeah, because I'm inside the JCI interpreter. Okay, so this is the Stack project, which is called Real World Haskell Chapter 10, and I also have like recording software here and other console, which I use like when I need to do long things, but that's not important. So let's talk about Haskell or another technical things. This series is not supposed to be a real like impediment on my learning style, so I will edit this very few, like I will edit this not that much. I will try to edit it live, but it will be very raw in its presentation. If it becomes like something, if it gains views or stuff like that, I will then maybe bump up my editing skills. So we are programming in Haskell. We are making a graymap parser. A graymap file is an image format file. I have one in the assets directory of my folder, and it is of course lolcat, and it is also a black and white picture because PGM stands for portable graymap, and a graymap is of course black and white picture. So we can view that file using Vim, which is just a text editor, and here it is. As you can see, it has a version specified here. First line, second line has width and height, third line has the maximum gray value, and the rest of the file after a new line is just a byte string, which contains, in every byte it contains a number which goes from 0 to the maximum gray value specified, which is 255 in this instance of file, and this value represents the amount of gray. So like here we have like 0 blackness where the text is. The gray of the lolcat has a little bit of black in it. Okay. Alright, so I wrote like a structure which will contain the parse the data, and I set up a skeleton to parse it. So let's test the skeleton. Alright, so I'm going to write a parse PGM function it's going to accept string, and it's going to return the gray map format. So let's define this as undefined. Yeah, of course I will need to accept the document. Okay, and so right now it should compile. Let's see. It doesn't. It has an error. Okay, in the second argument of dollar, namely parse BGM, put string parse BGM contents in the expression. Couldn't match type gray map with jar. Expected type string, actual type gray map. Oh. Yeah, I guess yeah, because I did put string, so I need to convert this to a string. Hoping this will work. Let's see. Oh no, it's show. Yeah, it's a show function. It's like the standard way to do these things. Yeah. I don't have vim commands. That's a pity. So we need to reload. And it doesn't have any errors this time. If I do main, I get a call to undefined, but it works. If I return the string undefined, we should see like we need to reload, of course. It doesn't work. Oh yeah, it's not a gray map, of course. So let's return a gray map. So you need to do this and pass it as a tuple. Let's see, 1, 1, width of 1, height of 1, gray value of 1, and the contents of an empty list. I derived show. I think we will need to implement our own version. Okay, so it doesn't work. It only wants an int. To be honest, I don't really know how structures work that much. So I guess I will need to let's see, Haskell structs. Yeah, see, I don't know if to edit this out. Well, not C structs. I think it's called records in the technical. Yeah, I think it is. Okay, so I say Haskell records. So they are basically structures if you know C programming, but I forgot the syntax. Here it is. Yeah, they are like within other things, but I want to know to construct them. Yeah, I don't know. Let's see if like real world Haskell has a chapter. Okay, so using type classes. So I guess I will see to this and then. No, here it is, data structures. Okay, I will not edit this out. Association lists, I don't care. Let's see. Okay. So records only have one occurrence of that word. Yeah, I think it's not what I was looking for. I think it isn't defining type. Should be. Okay. Bracket syntax. Yay. Okay, so yeah, of course. Okay, still doesn't work because we don't need the things. Okay. So yeah, in Haskell you have functions. You call functions by just calling them. Like in Lisp, you have this syntax, and you can omit the parentheses, and it will call the grammar function with these parameters. You need commas, it's just very clean, and that's the constructor. Okay, and it prints it. Yeah, it works. Okay, can can I do it on a single line? Let's reload and let's do it again. Yeah. Okay, so I guess now we just need to implement it. Okay, so okay, first of all, we will not read it as a byte, as a string. We will read it as a byte string because yes, I showed you that we if we look again at the image, it has a byte string component, so we don't want to interpret this as a literal string, but we do want to interpret these as ASCII because they are ASCII by convention. So we need like an hybrid thing, and the way to work on hybrid strings which contain a byte component and a UTF-8 component is to use a library which is built for that purpose, and that library is specified in the tutorial, and I do not remember the specifics of it. So let's go see code case study parsing the binary data format. Yeah. So yeah, I tend to, when I read books, I tend to read them only when I need to. I read them like I read all of this, and I try to remember as much as I can, and now I'm trying to reproduce it without reading it like again. That's how I do it. So yeah, as you can see, there's like this L dot everywhere, and this is because he imported these things. Okay, so we need to import. So this is how you import. You can import qualified, which just means that you can use the as thing and that byte string, that lazy, that car8. So this is the library, and it just uses lazy strings because, you know, why not? And also uses this. Okay, so this only parses byte strings as byte strings. It has like utility functions for reading bytes. This, on the other hand, is for reading byte strings as if they were valid UTF-8, which is going to be needed for this section. In this section, we're just going to use, you know, the normal byte string processing functions. Okay, so yeah. So we now need to read a byte string. I guess we can just read a string and make it a byte string using the pack function, and we will pack it using the as if it was a UTF-8. We will then pack it, and it will now be a byte string put into content. So let's see if it works. Stack GHCI, which loads the main module. So it does not work because the brackets do not match. Oh, that's weird. Oh yeah. You don't know why I erased it. Empty. So let's reload. Okay, so now I need to import this, and this is a nice opportunity to explain how I came to create this project. So what you do is, what even is this? No idea. So what you do is open a terminal window, go to the desired location, do stack new name of the project. I called it Reward Haskell Chapter 10, and then put a template. I put simple as my template, and it then builds a directory, which in my case is this, and it puts a bunch of files in the directory. The most important one is this file, because it has things that to do with dependencies, you know, these, and